Today's lesson, we're on Unit 13, Lesson 4, Distributions of Multiple Samples. We'll be covering 3 pages, pages 458 to 460. It's helpful if you have a calculator, the graphing calculator, because we will be doing some stat edit, one variable statistics, and a highlighter. And the homework is 3 pages, pages 461 to 463. So we've learned about the importance of choosing a sample randomly so that the sample represents the population. If a sample is chosen with good methods, it is still possible for the data from the sample to be different than the data from the entire population. If it is possible, how can we ever make any decisions from sample data? This is a question we'll be answering throughout the rest of the unit. So we have this first exercise as an activity that we would have been doing together in a class, well actually kind of in your with your seat partner, where each group of 2 persons would have a bag of beans. So what I'm going to do is I'm going to run through it, and then I'll stop the video and probably work through it another 25 to 30 times. So we have, what we want to do is this bag here, right? And I'll tell you it contains 100 beans. Some are tan, some are red. Each group of beans is 40% red. So if it's 40% red and there's 100 beans, then how many beans are red? Well, there would be 40, because 40 out of 100 is a population proportion of 0.40. Which is the same as 40%. So what I'm going to do is, I'm following the instructions here. I'm going to select a sample of 20 beans. So I'm only going to take a sample of 20 beans out of this bag by taking a handful and then selecting single beans until there are a total of 20. Count the number of red beans in your sample of 20. And we're going to I'll write the proportion of red beans in the sample of 20. So this is my population of 100, but I'm taking a sample. I don't want to count all of them. Just going to take a sample of 20. So I took a handful, and let's see, 2, 4, 6, 8, 10, 12, 14, 16, 17. So I need 3 more beans. There we go. Now, so I have 20 beans here. How many of this 20 bean sample are red? 2, 4, 6, 8, 10. Let me double check. 2, 4, 6, 8, 10, 11. Good thing I double checked. And so there should be 9 tan beans. 2, 4, 6, 8, 9. Okay, so I have the proportion of red beans is 11 are red out of 20. And as a decimal, that is 0.55. So every person in the class would be doing this. From the bag of beans, you're going to take out a sample of 20 and then count the proportion of red beans. 2, 4, 6, 8, 10, 12, 14. So I got 14 beans there. 15, 16, 17, 18, 19, 20. All right, and of these 20 beans, 2, 4, 6, 8, 10, 12. 12 out of 20 are red, which would be 0.60. All right, so I'm going to do this one more time, and then I'll pause the video and get all the other proportions. So I want to pull out a sample of 20 beans. That might be a little too much. Let me see. All right, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right. Out of these 20, how many are red? That's 5, 7, 8, 9, 10. Okay, so now I'm going to pause the video and do this several times. Okay, so what I did was I did that for a total of 35 times. I drew out 20 beans and counted the number of red beans out of the 20 and wrote the equivalent decimal. So, and I made tally marks is what I did. And then I put them on this dot plot number line. Okay, so this is the sample proportion. We're at a sample of 20 beans. And this is a sample of how many red beans from that sample of 20. So this graph is the sampling distribution of sample proportions. And again, you don't have this. This would have been placed up on the whiteboard. One thing I want to notice, all right, before I answer these questions, is look at the spread, okay? The spread is the low to high, right? The lowest proportion is 0.15 and the highest is 0.65. So the spread is 0.15 to 0.65. And this is a sample size of 20. The sample size is 20. Describe the shape of the distribution. It's definitely mound shape. You might consider it a little skewed left, but it is definitely mound shaped. The smallest sample proportion is the 0.15 and the largest is the 0.65. What sample proportion occurred most often? It's the 0.50 had the highest. That occurred, I believe, 7 times. 2, 4, 6, 7. Yeah, 7 times. So 0.50. Using technology, find the mean and standard deviation. Okay, so to save time, I have that in my calculator already. So I would have, we would have gone to Stat, Edit, and in L1 we would have placed the sample proportions, and in L2 the frequency, the number of times each sample proportion occurred. So like you see here for 0.35, the frequency was 4, that occurred 4 times. And now Stat Calc, 1var statistics, enter. The list is L1, and if frequency list, we'd have to paste L2 in there. Remember, to get L2, that is simply second number 2 is L2. All right, so the 2 lists are in there. So our mean is our X bar, 0.45428. We want to round to the nearest hundredth, so I'm going to say X bar equals 0.4542857,143, and then I'll round. And then this is our sample standard deviation is the capital S sub X, 0.110061, 0.110061. We're rounding to nearest hundred. So the mean is 0.45. and the standard deviation is 0.11. How does the mean of the sampling distribution compare with the population proportion of 0.40? Well, it's close to the mean. 0.45 is close to 0.40. If we were to take another sample of 20 beans, give a range for the proportion that we would expect to occur. What we would expect to occur is what we call a 95% confidence interval. What is expected, if we remember back to our normal distribution, or I'm not sure what page it was on. It was on the bottom of the page. It was in a box. It's the mean plus or minus 2 standard deviations. You have to memorize that. You have to know that. What we expect to occur would be a range of values between the mean plus 2 standard deviations and the mean minus 2 standard deviations. Okay, so in this case, I take the mean of 0.45 plus or minus 2 times 0.11. And 0.45 plus 0.22 is 0.67. And 0.45 minus 0.22 is 0.33. So our range, we would expect a proportion between 0.33 to 0.67. In exercise number 2, what do you think would happen to the sampling distribution if everyone in the class took a random sample of 40 beans from the bag? So instead of taking 20 beans, a sample of 20, and finding the proportion of red beans out of that 20, what if we took a sample of 40 beans? Well, to help answer this question, we could repeat the process described in exercise number 1, but no, I'm not going to go through that, recounting again. Or we can use this simulation here. So to make the process quicker, a simulation was conducted where each student in a 30-person class took a sample of 40 beans from the bag. The proportion of red beans is shown in the dot plot below. Well, first I want to note the spread. Okay, look at the spread of this. This is a sample size. This is a sample size of 40 beans. Sample size is 40, right? And the spread here is from 0.30 to 0.55. So we have a smaller spread with a larger sample size, right? If we take a larger sample size, the spread gets smaller. Describe the shape of this distribution. You know, it's definitely mound shape, even though we don't have a center peak. They definitely still have this mound shape here. What is the smallest sample proportion? That's our 0.30. And the largest sample proportion is the 0.55. What sample proportion occurred most often? Well, there was 2 of them. Let's see. There's 0.375. And the other one, midway between 0.40 and 0.45, 450 is 425, 0.425. Okay. Again, right? The larger the sample size, the narrower the spread. If we compare that back to, sorry, here, it's easier here. What I had on the other side, right? Here our sample size was 20 and our spread was from 0.15 to 0.65. That was a much larger spread. Using technology, find the mean and standard deviation of the sample proportions in the dot plot to the nearest hundredth. All right, so this is where, and the table is kind of filled out for us here already. Here are the list of proportions from the dot plot above. So that would go in L1, and the frequency is also noted for us already, right? The proportion of 0.30 occurred once, 0.325 occurred once, 0.3 or 0.35 occurred twice. All right, so this would be L2. So if you have your calculator, and just for practice, if you would just, key it into L1 and L2, and then go through your calc, stat calc, 1-bar statistics. Again, to save time, I do have it in here already. All right. Here's my L1. There's the frequency L2. And now stat. Arrow over to calc. We want one variable statistics. So the first one, enter. And again, you do have to have L2 in the frequency list. If it's not there and I press stat, calc, if it's not there, all right, it's telling me there's only 11 n values, right? So meaning it just took all of these proportions. That's it. It did not read the frequency list, all right? So I go back to stat, calc, and now put L2 in for frequency list with the second number 2. Now enter, enter, and now our n value is 30. Right, because there was 30, this was a 30-person class. So the number of dots here would be 30. All right, so we want the mean and the standard deviation to the nearest hundredth for this. So our mean is 0.425, and our standard deviation is 0.0636, nearest hundredth. Okay, so our mean is 0.43, and our standard deviation is 0.06. How does the mean of the sampling distribution compare with the population proportion of 0.40? It's close. 0.43 is close to 0.40. If you were to take another sample of 40 beans, give a range for the proportion that you would expect to, a range for what we would expect to occur is your mean plus or minus 2 standard deviations. Right. That's what we would expect. This is a 95% confidence interval. The range we would expect is the mean plus or minus 2 standard deviations. So I take the mean of 0.43 plus or minus 2 times the standard deviation of 0.06. 0.43 plus 2 times 0.06 is 0.55. Arrow up, grab that, and minus 0.31. So our range we would expect from 0.31 to 0.55. As the sampling size increased from 20 to 40, describe what happened to the sampling variability, the standard deviation, right? The standard deviation decreased. Our standard deviation for the 20 beans was 0.11. Our standard deviation with the sample of 40 beans was 0.06, almost cut in half, actually. What do you think would happen to the standard deviation of the distribution of a sample proportion if the sample size for each sample were 80 instead of 40? The standard deviation would decrease again. The larger the samples, the smaller the variability. The larger the sample size, the lesser or smaller the variability. Sampling distributions of sample proportions can be used to see if a single sample proportion could have come from a population with a set proportion. This is our situation. A high school principal claims that 50% of the school's students walk to school in the morning. A student attempts to verify the principal's claim by taking a random sample of 40 students and asking them if they walk to school in the morning. 16 of the sampled students say they usually walk to school in the morning, giving a sample proportion of 16 over 40, which is equivalent to 0.40. So this is our single sample proportion. Could the principal be correct that the proportion of all students who walk to school is 50%, our set proportion? Exercise number 3. To determine if the principal is correct or not, the student conducted a computer simulation with a sample size of 40 and a population proportion of 0.50. She conducted the simulation a total of 40 times. So there were 40 trials here. So here we would have 40 dots. This is a dot plot of the computer simulation. For the sampling distribution, the average proportion, average is our mean, is 0.493, and the standard deviation is 0.085. We are 95% confident that the actual proportion of students that walk to school in the morning is between what two values? Well, our 95% confidence interval is found by taking the mean minus 2 standard deviations and the mean plus 2 standard deviations. Our mean is 0.493 minus 2 times 0.085. We go to the calculator. 3.23, sorry, 0.323. And then our mean plus 2 times the standard deviation. So arrow up, grab that, change the minus to plus, 0.663. So this is our 95% confidence interval. We're 95% confident that the actual proportion of students that walk to school in the morning is between 0.323 and 0.663. Could the principal be correct? Based on our single sample proportion of 0.40, does 0.40 lie within this interval? It does. So our answer is yes, because 0.40 lies within our confidence interval. Of 0.323 to 0.663. Okay, so just in summary, please, you have to memorize when we are looking for a 95% confidence interval, which I'll abbreviate CI. You take the mean plus or minus 2 standard deviations. That is x bar minus 2 times the standard deviation, x bar plus 2 times the standard deviation. For the homework, you're going to construct a dot plot from these proportions here, and then describe the shape. So very similar to what was done in the lesson today. Your 95% confidence interval, it's just the mean plus or minus 2 standard deviations. The thing is, you will need a calculator to, put the data in and do your stat edit, put the data in, and then stat calc to get the one variable statistics to get the mean and standard deviation. Just in case you don't have a calculator, to do that, remember you do have, I think a lot of you, if you don't have a calculator, you have it on your phone, right? This is just mine. If I can get back to the original, I'm not sure. Where's my calculator? There it is. This is the calculator 84 right here. And I do stat and then edit. I wonder if this is the data I have in here. Edit. Yeah, I think it is actually. Yeah, I use my calculator to put the data from this dot plot in. But please, you do need the practice, so just don't copy the mean and standard deviation that I'm going to give you. What did you stat? Calc. And for the one variable, so it's this one, the first one. And then I just have to key in, I think I need parentheses, L1, second one, comma, L2. And close the parentheses. And so the mean to the nearest hundredth is 0.67, and the standard deviation is 0.11. So those of you who don't have a calculator, 0.66, sorry, I think I may have misspoke there. And the standard deviation is 0.11 if we're rounding to the nearest hundredth. Okay, so again, you've got the 3 pages, and very similar to what the lesson was about. Thank you once again for your attention. I better check that before I sign off.